Yuki.
Okay. So I'm going to ask you a few questions, nothing really personal, just a little background history about your education and things like that. But can I first get you to state your name?
Okay. Professor Remy Yuki.
Okay, and what is your position?
I'm the department head of the chemistry and physics.
Okay, and how much time have you worked in this department? Like how?
At PV or?
PV.
Okay.
Yeah.
I believe I've been here for close to 17 years.
Oh, quite some time.
Yeah.
Okay. Yeah, that's really nice. Okay, what is the educational background and which schools have you attended? What is your educational background and what schools have you attended?
Okay. I had my bachelor's in chemistry and then my PhD in chemistry. I did my undergrad in Nigeria as a chemist, and I worked briefly for a big company for about 4 years. After which I decided to do my PhD, move out for my PhD, and I did my PhD in Wyoming. This is Wyoming, and after that I did my postdoctoral appointment in Dallas at Southern Methodist University. After which I moved to New York. So I was in a Long Island University in New York for 12 years or 13 years. I was a professor there, and then I moved over back to Texas, to the chemistry department.
And that's when you started here.
Yeah.
You have a really long career of chemistry.
Yeah.
What is the current specialization in the research area that you are currently working in or have worked in?
Oh, I'm working in diverse areas. Again, my primary area was initially in organic chemistry, and then plus in organometallic chemistry. Organometallic chemistry is just a blend of inorganic and organic chemistry, where we are trying to explore more of the metal-carbon interaction. So I've worked in different research areas that involves a group of compounds that we call carborane. Carboranes are like the inorganic, getting close to the inorganic type of, you have carbon-carbon bond, but you have the carbon-boron bond, and let's look at the beauty of the molecules around the area. I've worked on metacatalysis and catalytic reactions, and I've also worked in biomedical application of inorganic chemistry. For example, we've worked on
I'm sorry, did you say
biomedical application. We've worked on making inorganic material for bone repairs and bone tissue engineering. Now we also work on plasmonic agents for cancer therapy. So we try to look at novel type of inorganic molecules or inorganic compounds that exhibit some unique properties that can be applied into medical field. And then currently we work on nanomaterials or nanotechnology, nanoparticles, which are a different kind of material that teaches us a different type of thinking as a chemist and the way we look at things. So it's
That's really interesting. I'm actually kind of interested in the cancer, like when you said about the biomedical history. I'm actually want to go into my major just to kind of work along with something of that sort as well.
Yeah, that's good.
What motivated you to become a scientist?
I've always loved chemistry right from when I was in school, and then I also see chemistry as more of a central science, and that it actually. Well, initially I was a bit naive, thinking that you can solve problems as a chemist. You can make anything, which is true in the real sense. But these days and age, we have far more knowledge when you actually combine all of this, your limited knowledge, and then see what the interdisciplinary factor. Because things are changing, the way we see molecules are changing, the way technology comes out is changing, and then the way you learn chemistry, you have to go back again and learn more to be able to function in the realm. In fact, now when I say someone is a biomedical scientist, really, can say it's chemist, you can say it's a biology, you can say it's a physicist. In fact, some of the discoveries that people get Nobel Prize on now are done by physicists who actually also work in the chemistry field. So it's a very, very diverse field now that, if you're not interdisciplinary in science, you can easily be lost.
That's true. What are the highest aspirations for the students that you teach?
The highest aspiration, well, I always want students to aspire to be who they could be. And I also think that you can always achieve what you desire to be, but one of the things you have to work hard and you have to be serious about that. And once students are able to do that, you want to work with them to achieve that, which is the success of everything is, you go back and look back and you see your students doing so well in what they chose to do. Our students growing up who have worked in my lab, who are medical doctors now, our students who are professors at the universities, because I call them colleagues now. And so it's always a joy when you see success in them.
How does your scientific training impact the way they think and see the world?
Well, the ones, again, if I can say, I've had students who did research with me, who work for me, and then the kind of training we give them, and the kind of knowledge, and the kind of way expectations from them, slowly develop them to be independent thinkers, independent learners, and how to gather knowledge. And a lot of them have excelled on that path. The education nowadays is different from the way when we were growing up. When we were growing up and you want to go say, okay, I want to be doctor, I want to be this. They say, well, to start with, you have to go with math, English, and then mostly math, English, right? And then the sciences, and then go into those fields that you admitted you do this. But these days, the way people learn, those days you have to memorize, get books, and imagine things. You have to memorize. But these days, the kids these days are the learning tools we have all around now. It's not geared towards memorizing. Those things are easily accessible to them. The knowledge skills are being reinforced by so many tools that we have now, that even we as professors have to keep learning how to use them. For example, when I was in chemistry school, I basically had to memorize my periodic table. This element. But now, why would I ask a student to memorize periodic table when they have access to those things? The certain tools in math that used to be very, very, tough for me. Now the students now have access to a calculator that does all those things for them. So now, so the key thing is that you want to help them develop that knowledge now to be independent thinkers, because they can. I always question myself: do we really? Say you want to go into medicine, right?
Okay.
Over there, a kids of 10, 15-year-old playing with the computer can gather all the knowledge he or she needs to be well. While I was growing up, those things were not there. With English, with math, with all of those things, there are tools that are like games that actually expand their knowledge so wide. So they have so much access to do well compared to what things were in those days. So they can think faster. They can be more innovative compared to what was happening then.
Okay. So basically, like the new technology and all the kinds of stuff, like inventions that maybe progress, like maybe like. Say for instance, like the calculator and stuff like that. How am I trying to form the question? Sorry. So basically, the new technology has made it much easier for the students these days to learn and access, such as like computers and things like that, to access the information.
It makes much more access for faster. When you're young, your brain cells develop faster. You learn things easier, and then you have the tools that are available for you, right? Then you can start things that we in terms of innovation, the way we see things then and the way people could easily see things now is so easy. You don't need to spend so much years in college to prove you're good.
Yeah.
Right? I mean, students can actually develop themselves from the tools available to them that will enhance their learning. So again, it depends on if the student is interested to be,
Yeah.
on that path.
Thank you for answering that question. Thank you for understanding what I was trying to ask. What is your ideal dream as a scientist? Maybe like such as things like Nobel, like to win a Nobel Peace Prize, or like discover something exciting, solving something great, etc. Like, what is your ideal dream as a scientist?
Well, my ideal dream is to have my contribution to the scientific world, which I've been doing through my publication, through my research, through my these things. If all of those things now happen to make a bigger impact in science overall, and I've been recognized for that, I would strongly appreciate that.
Mm-hmm.
But it's not my dream for now. But my dream is just to make an immediate impact on my students, on the science, on my reputation as a scientist, and my publications, and the things I do.
Okay, thank you. So what are some final words that you would encourage me, myself, her, or any other student who are going to watch this video?
Well, my final word is that these kids these days are more talented, are smarter, and then you have the tools to excel to whatever level you can imagine yourself you want to be, but you have to dream it first, and then you have to work towards achieving it. And then you have your teachers who are themselves learners, right?
Yeah.
Working with you, and then just take advantage of all of these resources you have.
All right. Thank you.
Okay.
That'll be the end of it. Thank you.
Okay.
Thank you for your time.
My pleasure.